Hello, Professor. My name is Asad Khan, and I have to present my first research paper. So the title of the paper is Design and Analysis of the Leader Election Algorithm for the Mobile Ad Hoc Network. So first, with introduction, what is ad hoc network? The mobile ad hoc network or the wireless network where device node communicate directly without relying any fixed infrastructure. So actually, that is the connection between wireless, which have no wire connection or any infrastructure. So the network topology continues to change and device move. So that is really the no wireless in the no apex infrastructure for that, just like the router, they are connected to each other. So they continuously move to each other. So the topology, the network is usually changed. So the mobile ad hoc network is a type of wireless network where device also called node and communicate directly with each other without relying on any fixed infrastructure like router or just like router or access point, and this has a wireless connection between each other. We have no the fixed infrastructure. So the key characteristic of that is a decentralized structure. They have no central authority or server. And they have dynamic topology. The network structure continues to change because they have no central authority or server, so they are changed continuously. So what are the leader election needed in mobile ad hoc network? So in mobile ad hoc, there is no fixed infrastructure to manage the tasks such as routing or resourcing the allocation of the nodes. So the leader election is required to ensure effective routing decision, managing the network resource and coordinate activity among the nodes. So in mobile ad hoc network, there is no fixed infrastructure to manage the task, just like routing, resource allocated, or node coordination. The leader election is a process. They have elect the one leader to act as the temporary manager for the network. So just like in another network, they have a fixed infrastructure, just like a server. So they act as a manager and control everything. So the leader had to ensure efficient energy routing, then optimizing routing path and updating network topology, because they have continuously change the topology just because of the dynamic nodes. So the problem statement here is challenging in the mobile ad network. Is the first one is dynamic topology, is because they have no server, so the nodes are moving. Nodes are moving. They have connection change between them. Just like in a city, we have the mobiles. They are a vehicle in the road. They have in wireless connection. They have continuously change their location, and they make it difficult to maintain a stable network without a leader. So the without a leader, this are difficult to maintain the stable network between them. And the second one is energy constraint. So the mobile devices have limited energy and cannot support continuous communication for long period. So the making efficient. So we make the algorithm, not algorithm. So this will be efficient. It's necessary for the mobile data network. The other one, scalability, as a large number of nodes in the network increases the ability to maintain efficiency. Just in wireless connection, if the wireless are increases, the number of nodes are increases, there will be difficulty to communication and to maintain efficiency, and that will become challenging. So the leader election need to scale well with the large network. So that will be scalable for the large network. The leader election issues is the first one, existing algorithm often struggle in dynamic network, leading to high communication overhead, too many message being sent. So because of the in the large network, that will be uh, overheaded to send message being and efficient energy uses, and the other one be slower reaction time to change network. The purpose of algorithm is to design algorithm to elect a leader and distribute efficient system to manage the ad hoc network. So the key feature of the algorithm will be to distribute all the node independent participant in the election process. So the first one is will be all the node or will be participate in the election independently. And the second will be localized communication. The node communicate only with their immediate neighbor and reduce overhead. So they in this algorithm, so the localized node will be communicate with the neighbor node to reduce the overhead of the message. And the third one will be there will be a dynamic re-election, and if the current leader are failed at this some if the energy are down, the battery are low, so they will be elect a new leader. So the algorithm, how will we work the algorithm? So the starting the first if the trigger the election will be start when it detect to need a new leader, when it happen if need to elect a new leader. So the second that will be create a tree. So the first node started the election and they will be send a message to neighbors. So this will be it is create just like in a farm of tree. So the each neighbor will be pick the message and that will be sent to its parent and that will be forward the message to its own neighbor. So this will be how will be does it will work the algorithm. So the first this will be find the best node. So the best node will be they speak of the base of the priority. The node at the end of the tree, leave node. The send will be message acknowledge message to its parent. The parent will be information about the best node. So they will be know about the best node. At the top of the tree, the source node, the best node leader is identified. So this thing, the best node will be identified. So the fourth number is announcement, the leader. So the source broadcast leader message to the will be let to everyone to know who will be the leader. So the flow of the algorithm will be the first one election will be started. So they'll be send message to neighbor. Then the second will this will be create in the form of tree. So the node will be connect to its parent and then will send back message to the send will be the back message, and the last one it will be choose a leader. So the priority calculation, how is the priority will be calculated of the leader node. So the priority it will be the priority will be calculated about the node degree. That's how the node with the more connect the node that will connect more its neighbor. So that will be better connected and it's prepared. And the second one is stability. So if the mobile node are prepared as they provide stability, and the third one will be with their matrix. This ensure the leader is not only capable of performing a task, but it also will be remain in the network for a long time without failing. The third one is they will be depend upon the energy of the nodes. If the node have high battery level, so they will be remain long time in the network. In when will occur the dynamic re-election? So it will be occur the dynamic re-election if the leader become unavailable just because of the node failure or the battery is drained or something node are crashed. Basically if the wireless are crashed, so the node will be failure. That's and the second will mobility. If the leader move out of range, if the node are move out of the out the network, so this will be failure. So so in this situation the dynamic re-election will be offered. So the importance of dynamic re-election is to network stability, ensure that the network stability by only having a leader in charge. So they will be the network stability just because if the leader has failed, so the re-election will be occur and the network will be remain same. Prevent communication from if the node have any problem with the other network. So that's why the problem route in resource management. So the re-election will be often if the leader node have communication problem with another that's neighbor. So if they have problem in the communication, so that's why in this situation the re-election will be occur. And the third one, and another one is the ongoing resource management. The leader manage things like just energy and bandwidth. If the leader gone, so this will be the re-election will be occur. So the experimental result at simulations. So test and invariant network that are tested in network just like the size of 100 node and different mobility pattern, just like different mobility that's we're talking about the devices. So the key result is to reduce message overhead. So the purpose of this algorithm is to reduce communication overhead and to reduce communication overhead. So just because if they have select any node, so they will be sent any information, so they will be sent to the leader and they will be sent to overall the node. So this why the message will be overhead. Scalability perform efficient in the network size increase. So they will be perform efficiently if the network size is increased. And the other one, robustness successfully adopt topology change and the leader page. So there will be a successful adopt if the topology change if the node move from one area to another area or the leader failure. So they will be able to adopt these things. So the strength and weakness of these algorithm is so they energy efficient just because they receive communication help to convey battery life, and the other is scalability. The work will in both small and large network, and the other adopt a leader fail. If the leader is failed, so they will be re-election and they will be announced in the leader. So the weakness of this algorithm is to re-election delay. If in large networks, so there will be re-election, or so there will be take time. Uh, mm, and the other one, the other one assumes similar node capability. So the first one they have picked the node because of their priority as the battery and then the neighbor connection. So if the node have same connection and same energy, this will be different to pick the leader. So my personal view, critiques and recommendation is, so the personal view is the strength of this algorithm is to they are they will in a dark network where devices are continuously immune to each other and they have no central point. So it helps to solve the problem by selecting a leader to manage a network and efficient because it reduces the number of messages sent between the devices, which help to save battery and reduce the data usage. So this algorithm is meaning and handle situation when the leader devices fail or leave, so the battery are down or the devices are crashed. So it can pick the new leader without disturbing the network. So the challenge of this is that these algorithms is that all devices are the same. So this is the challenging part. This is to show if the network, the all devices will be same, but in real devices, but maybe the devices in the real life, if you these communicate these, this will be different devices will have different battery life. So power and stability, they could make algorithm less. In this way, the algorithm will be less efficient if the device are the not same. The critiques, so the testing, the algorithm will simulation computer model, but it will be need to test in real life just situation, and the network have behave differently. The devices have energy level are moving unexpected way. So the second one is security. So they have proper does not talk about the security. If they have an ad hoc network, they may be joined and continuously the another devices. So there's maybe have no security. And they have no security rule. This bad device try to miss with the leader election. If the some unauthorized device are connected to these and then become the leaders, it will be security threat for the overall network. And it could be the cause problem that it does not have the belt way to prevent this. So this algorithm it does not have to if they re-elect any other unsuspected leader. So that's maybe the security failure. And the second was a leader election delay is also delay. They take a time if the leader or fail at the battery or their crash. That's maybe take a time to especially in large network. That's maybe take a time to re-elect the leader. The recommendation is My recommendation is to test this algorithm in real life. The need to test in real life and disasters. Disaster here, the infrastructure will be destroyed. So this maybe they are use the mobile dog network are especially used in that area. So they are connect communication between without any infrastructure or any server. And just like an emergency service or moving car, so they the security moving car or any other. So they have now tested in real life. And also to add security feature, the algorithm should include to protect against attack if any unsuspected devices are connect and they become the leaders, it will be a security failure. To make it, and the other one is to make it for different devices. So the same is this the same devices they so that's not possible. Maybe to all devices will be same. Other different devices, some devices may be stronger battery, some may be the less power. So that's the device capability to sure it will be all the use will be for all different devices. And the another one to speed up their leader re-election, especially in large network. So the conclusion of this leader election mobile hard network help choose leader to manage the task that like to that's use actually used by this to manage a leader but task just like routing, switching, writing resource, allocating and efficient save energy and they exchange the messages so they may be overheard the message and they will easily exchange the message between the devices. So the strength of this device is to challenge the environment where devices are move around and that quickly choose the new leader. That's maybe they keep the network stable. So the area to improve that is to algorithm assume that all devices are same. So the one failure of this is they said that all devices will be same, but in real device may be different capability just to capability about the battery power and other thing. And the other one will be the re-election of the leader and could be a large network. So that's maybe delay if the network is too large. That's in the examination question. Thank you.